Hello, Sing students. Welcome to Lesson 4 of Robotics, Mechanical Aspects of a Robot. The quick overview is we will be learning the basic review of motors and servos, and we will be learning a lot about assemblies and everything that has to do with them. Now, before we begin, what are you learning in this lesson? Well, we will be learning about the mechanics behind many robots we see in our life, as well as answering the questions: what are motors used for, what are servos used for, what assemblies can we create with these, and lots more. Now, you may be wondering, well, why is any of this important and why should I care? Well, it's important because in robotics, it's almost a requirement to know what assemblies are, as well as how to complete tasks efficiently with the tools you have. By the end of this lesson, you should know what assemblies are, how to use/ come up with one, how motors and servos work, and when to use them. Now, onto the basic review. What are motors and servos? Well, motors and servos are machines which allow us to turn electric power into motion. In this case, it will be rotational motion. The difference between a servo and a motor is that a servo only rotates 180 degrees with increased accuracy, while motors have a full 360-degree rotation with a lot less accuracy than a servo. Now that we know what motors and servos are, we need to know where we use motors and servos. Well, for servos, we should be using them whenever we need precise movement, like in robotic arms or RC vehicle steering. On the other hand, if we need consistent and constant movement, we should be using a motor. For example, with fans, drills, or blenders. This takes us to the next thing we need to learn about: assemblies. In your mind, you might be thinking of factory assembly lines or school assemblies, which aren't actually that far off from what they are. You can think of assemblies as a bunch of different building blocks or parts coming together to create a larger structure. As you can see in the image, one block on its own isn't that impressive or complex, but put it all together and you can create a whole city. This is a great thing about assemblies. However, we can sneak in another smaller assembly and create subassemblies. Subassemblies are basically the same thing as an assembly, but it's smaller and something that fits into the larger assembly. They're like the different buildings. Each one is its own subassembly built off to the side to come together into the whole city. We've already established that assemblies are important to robotics. But why? Well, because especially if you do CAD design, when designing/ building a robot, things can get complicated really fast. So by splitting the bot up, you can make easier, more manageable tasks that can be divided up between team members. This makes the building process efficient, easy, and fun. Now that you know what assemblies are, I want to know if you can tell me how many assemblies are included inside of this bot. You can pause here if you need some time. Ready? If you guessed 3, then you'd be correct. And it's okay if you didn't. Sometimes it's really difficult to just look at a robot and divide it into subassemblies. Moving on, we'll look into more subassemblies in robotics, like one of the most iconic, the robotic arm. The robotic arm is interesting because it could be an assembly or a subassembly, depending on what you're doing with it. Then, there's a really important but overlooked subassembly, the drivetrain. In many robotics competitions like FRC, almost all robotics have a drivetrain in order to move. If you can pause here and see how many other subassemblies you can think of that are in robotics. Now, finally, after all the talking, you finally get a chance to show what you know. In this activity, you will take however long you want/need to brainstorm your own subassembly or assembly and create a list of components you would need in order to create your masterpiece. Make sure to talk about servos, motors, sensors, and anything else you can think of. Try to be more detailed than my example. Have fun!